Alright, hello, and welcome to another episode of My Two Cent. As always, my name is Paul Emerson, and this is My Two Cent. This video is about my theory of opposites repelling like charges attracting, and it's directed specifically at Ted. I believe his last name is pronounced Brandons. I apologize if that's wrong, Ted. I'm not very good with names, so I'm sorry. But anyway, I want to read a quote that is a part of a conversation that you and I have been having over the past few days. I've been busy with some parental stuff, so I haven't been able to get back to Facebook as fast as I normally would be. But I am grateful that you took the time out to respond, and I want to address your comment. And it's a lot faster for me to do a video than it is for me to try to log into Facebook and type and all that stuff. So with that said, I'm going to read one part of a response that you made to me Saturday. And it says, Paul Emerson, there's an arrow pointing up. It said, that makes no argument against mine. Ad hominem consequence is not logical or a correct way of critiquing an argument. If you respect me or my intelligence, you'd respect what I say. In other words, don't lie to me. The reason why I chose this of all of the things that you posted is because, for one, you're implying that I'm lying to you. There's no grounds to justify the insinuation that I'm lying to you just because I simply said above that comment it says, then show me how it's done, Ted. As much as I respect your intelligence, Ted, you just repeated what you were told, and I may or may not have overstepped my boundaries in that statement, but the reality is that above that, in response to several posts that I made, your response to me was, Paul Emerson, that is incorrect completely. M1 and M2 are not inverse of one another mathematically when you analyze the function of magnetism. Therefore, the rule cannot apply. From that statement, I basically asked you the question that I asked you. As much as I respect your intelligence, Ted, you just repeated what you were told. Show me how it's done. Show me where I'm making my error, Ted. If you believe as strongly as you do that I'm in error, it should not be difficult for you to show me how and why I'm in error. I think that's a valid statement. You tell me that I'm wrong. You give me an explanation to why I'm wrong, but you haven't used your explanation for why I'm wrong to show me why I'm wrong. My experiment may be flawed. It may be incorrect, but my experiment is an experiment that shows why I at least believe that I'm correct. It shows exactly how I establish my understanding, not my belief, but my understanding. The experiment itself, whether you want to accept it as an experiment or not, is the how and the why. It's the actual experiment. It's not just me saying the inverse rule works. It's me showing why the inverse rules work. If what I'm showing is the inverse rule, I'm showing something. So you need to help me understand why this is wrong. Why is this behavior incorrect? You say it's because of magnetic flip, but there is no magnetic flipping occurring. Magnetic flipping is something that would occur inside of the actual magnets themselves, and that's not the case. The magnets are not undergoing a magnetic flip. You said that I'm labeling the magnets wrong, but that's also not the case, because the labeling of the magnets themselves is subject to the inverse rule. The understanding of the interpretation of the information that we are receiving from the using of the magnets is what the inverse rule applies to. All of the other principles of QM and physics that apply to our understanding of magnetism and electromagnetism comes from our understanding of the belief that opposites attract and like charges repel. The inverse rule applies to that principle, and from that you can describe correctly or incorrectly that opposites will repel and like charges will attract. That is how the inverse rule works. You asked me to show you a proof, but I don't have to, because the mathematical principle itself shows you that the correct answer to applying the inverse rule to opposites attract and like charges repel is like charges will attract and opposite charges will repel. The labeling of the magnets shows you that behavior. It shows you that magnetism is subject to the inverse rule. And that's what I'm trying to get you to understand. I've shown you the principles, and I'm explaining the principles to you. I've given you the math, but you're rejecting all of them. And you're rejecting them without doing the experiment. I would love for you to sit down with a camera like I did and actually do the experiment. Because if you do that, then you will see what it is that I am doing, and you'll be able to understand what it is that I am doing, and then you'll be in a better position to explain why I'm wrong in my thinking process, if I'm wrong in my thinking process. And that's where we stand on this, because until you stop telling me that I'm wrong and repeat the experiment, whether the experiment is biased or not, until you repeat the experiment, you will never understand what it is that I'm trying to apply. One of my Facebook friends, Joy, we Skyped the experiment, and she did the experiment in her living room just with text, and she got the same thing that I got. So that's repeatability. Science is about observation, experimentation, and repeatability. She repeated the experiment. She got the same quantities that I got doing the same thing. She did not experience a magnetic flip or any of that stuff. The magnets aren't labeled incorrectly. The understanding and interpretation of the information is where your flaw is where your misunderstanding. If you view a magnet, like I said in the video, magnets are undefined. When you look at the magnetic field, it has no value. The spin state of an atomic particle is absolute if they carry one charge. A stable bar magnet has both an attraction and a repulsive force. It doesn't have a positive and a negative force. It doesn't have a north and a south pole. It doesn't have a clockwise and a counterclockwise spin. What we observe is a force of either attraction or repulsion based on what we observe as two magnets interact with each other. If you have a magnet on the table by itself, your observation of it cannot tell you if you're viewing the attraction or the repulsion. You only can know those two things if you observe them interacting with each other. That interaction is subject to the inverse rule. That's the part that I'm trying to get you to understand. When you have two magnets interacting with each other, the force of attraction and the force of repulsion can be described as opposites attracting and like charges repelling. It is that observation that can be described incorrectly. We take that observation and that information and we apply it to the quantum. That means that we took a particle, a proton or an electron, and we fired it at itself, and we got either an attraction and a repulsion, and we assigned a value to one of the particles. So we use an electron gun to fire electrons at positively charged atomic particles. But see, they're only positively charged because we say that they're positively charged. That's where we can make our mistake. So we had a particle, and we fired it at another particle that was not the same particle as the particle that was fired. These two particles are subject to the inverse rule. They could be described incorrectly if our understanding is incorrect. And I'm not implying that all of science is wrong. I'm simply explaining what I have found. That's what science is about. What I have found is what I'm sharing. I could be wrong. I'm not afraid of being wrong or being incorrect. It's very, very possible that I'm wrong. But you can't ignore the information. I'm right in the sense that the inverse rule applies to the cosmological magnetic field. Opposites can attract and like charges can repel, and the inverse of that is opposites can repel and like charges can attract, and you can clearly see that when you're dealing with magnetism, with ferrous materials, so to speak. The quantum level may not adhere. I could be wrong on the quantum level. The quantum level may not be subject to the inverse rule, but the cosmological R level, where we can sit down with two magnets and play with the experiment and see for ourselves, I'm right on that point. I'm not gonna even try to retract my statement. I'm right on that. There's no, unless you can bring a really powerful experiment and show me exactly where I'm in error. What I have shown is good science. It's good science. It's a good experiment. If you want to critique it with another experiment. Show through an experiment where I made my mistakes. I had a guy tell me it was parlor tricks, that I was just shuffling magnets around on the table, just using deceit and deception to try to prove my point, to make myself seem smarter than I am. That's fine if that's your opinion, but don't just say it. Show it. If I took time out to make an experiment to show you my understanding, you should take time out and reiterate to me my own understanding.